This form must be turned in by 8:30 a.m. tomorrow morning. Make sure you have all sections filled out. If you turned a form in and you have not heard back, they have been approved. If someone's not approved, we will contact you directly. Tickets are on sale now before and after school and during Spartan time. For prom, need a ticket and an ID to get admitted to the dance. Post-prom sign up, make sure you do that. It's online. Remember, post-prom is not a school-sponsored activity. There are posters in the common, or you can get on to post-prom on the internet to sign yourself up. Juniors, those you want to decorate for prom, that is Friday. You need to notify the office and Mrs. Watterson by 3:15 tomorrow. If you're going to do that, you can be excused all day or any one or more particular blocks during the day on Friday. If you have any prom questions, if you come to the office, you can ask. All, please stand for the pledge. The flag.
Hey, reminder, you got a no-note quiz coming up. So, do this to fidelity. Just grab a scrap sheet of paper and fill it out. Try your best. No notes, no calculator. I know this stuff. Because what happens is if you know those triangles, then you know that chart. If you know that chart, then you know the whole circle. And that's what we get today. All right. Anyone who picked up a notebook off of my desk, that was the stuff I did not get to. I hate having a test on a maroon day because I never get to stuff. Everything that was over here I got to, so that stuff is taken care of. If you picked your notebook up off of my desk, I would appreciate you putting it back at the end of class. You can pick it up at lunch. Okay?
What's the schedule?
I just sent it on Remind. It's also right there behind Gwen's head. It's also posted outside of my room. It's also posted right there above my computer. One hour class, 5-minute passing. 1 hour class, 5-minute passing. 1 hour class, lunch. 51-minute class. Go away.
Cool. Got her? Coming.
To which I engage my inner 16-year-old and I ask, bruh. I'm enough of a klutz. I don't need obstacles. Yes, I'm judging you. It's like 28 degrees, rain, slush, and snow outside, and you're wearing sandals with socks. I'm not mad. I'm just disappointed. Is anyone still going? Couple? Okay. Checky, checky. Handwriting's not the greatest because we're speed running, but okay, we should be getting there where even if you don't have the chart and the values memorized, at the very least you got to have the triangles, right? And if you can do anything at the very minimum, if you're doing anything relating to special triangles, just put those triangles at the top of your paper. So you got something to look back at. Okay? It's like when you very first learned your trig ratios. The first couple of times you were doing stuff, you probably wrote SOHCAHTOA at the top of every paper, just so you had something to refer back to. Okay? Now, if you know these, which I've been harping on for like 2 weeks now, then today gets very simple. Whereas for 3, there we go. Okay, right where we left off. So everything that we've been dealing with so far has had triangles of varying sizes. And what we've run across a few times is that it didn't actually matter how big the triangle was, the ratio was always the same. I think a good example would be yesterday with our quiz, our review. We had one where it was like arc sine of 20 over 35, but I said it could have also been arc sine of 4 over 7. We had something like that in our review. That idea that the side lengths don't matter, the ratio between them is still going to be the same. That's why the cosine of 30 is square root of 3 over 2, regardless how big the triangle is. So here it comes. If instead I want to make a circle where the radius is 1. Doesn't matter where it is. Radius is always 1. We call that a unit circle. Well then, remember our circle was broke up into all these special triangles? What happens if I rework my triangles to be a radius of 1? And then I'll also put 60 on here, even though we should know that it's the same. Okay. Those special triangles, if I decide, nah, radius ain't square root of 2 anymore, radius is 1. Can you find the other side lengths? Divide by square root of 2. What is 1 divided by square root of 2? Square root of 2 over 2. You have to rationalize it, right? And then side lengths are always the same. The radius is now 1. How do I go from the hypotenuse to the short leg? No, the short leg is normally in the 1 spot. Divide by 2, right? It's normally 2 on the hypotenuse, 1 on the short leg, divide by 2. Okay. How do I go from the short leg to the long leg? Multiply by root of 3. This is now root of 3 over 2. The radius is 1. How do I go from hypotenuse to short leg? To long leg? What's the sine of 30? Y'all just did the chart. What's the sine of 30? 1/2. What's the sine of 60? What's the sine of 45? What's the cosine of 30? Cosine of 60? Cosine of 45? Do you see what happened when I made it a unit circle? In every case, those all became the sine and cosine of my angle, which means this as a coordinate, xy, will be adjacent and opposite. That means every single point on a unit circle is cosine theta sine theta. So that big ugly circle that I showed you, you said, how am I ever going to remember that? Do you know your special right triangles? Do you know your trig ratios? Cool, puke them out onto a circle. That is the unit circle. And I want you to think about every time in the last week and a half that you've had to draw the thing out and remember what quadrant I'm in and all that kind of stuff. It turns out it was always the same values. I could have just looked at the circle. Here we go. Starting with degrees. Let's get all of our angles on there in degrees. Starting at 0, work your way around the circle. What do we got? 90. Okay, maybe we're not really about going in order. Maybe instead you want to count by 30s. 30, 60, 90, 120, 150, 180. Keep going. Count by 30s. 210, 240, 270, 300, 330, and 360. Count by 45s. 0, 45, 90, what? 135. 180. What? I heard it. 225. 270. What? 315. 360. Those are all of my angles in degrees. In radians, I start at 0 radians. 30 degrees is equivalent to pi over 6. So count by pi over 6 and reduce them. 1 pi over 6. 2 pi over 6. Pi over 3. 3 pi over 6. Pi over 2. 4 pi over 6. 2 pi over 3. 5 pi over 6. 6 pi over 6. I think we know that one. 7 pi over 6. 8 pi over 6. 4 pi over 3. 9 pi over 6. 3 pi over 2. 10 pi over 6. 5 pi over 3. 11 pi over 6. And finally, 2 pi. That was counting by pi over 6, by 30-degree increments. Just like we did 30s and then 45s to fill out the circle for degrees, I'll go 30s as pi over 6. Now I'll do what? Pi over 4s. 0, 1 pi over 4. 2 pi over 4, already there and reduced. 3 pi over 4. 4 pi over 4, already there and reduced. 5 pi over 4. 6 pi over 4, already there and reduced. 7 pi over 4, already there, or now it's there. 8 pi over 4, now there and reduced. Okay, so you all just did that chart. You all have all of your trig ratios. Next to this circle, I want you to write that every one of these coordinates here is going to be the cosine of theta, sine of theta. So, y'all got the chart right next to you. Actually, let's start with our quadrantal angles, those coordinates. Remember, this is a unit circle. The radius is 1. So what is this coordinate? The radius is now 1. 1, 0, right? So I'm going to come along here and do u. This is 1, 0. What's that pi over 2? 0, 1. What's that pi? Negative 1, 0. Not negative 0. That'd be facetious. And down here at 3 pi over 2? 0, negative 1. And then we're going to fill in all of our cosine values and sine values in quadrant 1. What is the cosine of 30 or pi over 6? Y'all just did it. Root of 3 over 2. What's the cosine of 45 or pi over 4? Root of 2 over 2. What's the cosine of pi over 3 or 60? 1/2. The sine of 30 or pi over 6. Remember, sine and cosine go together with complements. If I know that the cosine of 30 is square root of 3 over 2, then I know the sine of 60 is square root of 3 over 2. If I know that the cosine of 60 is 1/2, then I know the sine of 30 is 1/2. Right? They always swap places. And because on a 45, 45, 90 triangle, my sides are the same, sine is cosine. Square root of 2 over 2. Now when I say I only need to fill in that quadrant, it's because think about this as a graph. Think about this in terms of transformations and reflections. Think about this in terms of reference angles. That's a 30-degree triangle. Who else has a reference angle of 30 degrees? The one immediately below it, the one beside it, which means that if this coordinate is square root of 3, 1/2, whomp, this is also going to have square root of 3, 1/2, but what's the only difference now? X's are negative. That's exactly how we make the unit circle. That's why I don't need to know the entire circle. I just need to know quadrant 1, because now I take all of the stuff from quadrant 1 and I move this to its reference angle, but negate x. Square root of 3 over 2, 1/2. I take this and move it over to its reference angle, but negate x. I take this and move it over to its reference angle, but negate x. I don't need to memorize what the sine and cosine are of 120, because 120 has a reference angle of 60, and 60 has a sine and cosine value of square root of 3 over 2 and negative 1/2. I don't need to memorize anything in quadrants 3 and 4. I just take these coordinates and I flop them all down here. This goes to its reference angle. It makes a bunch of boxes. It makes a bunch of connected areas where this goes to this, goes to this, goes to this, goes to this. Those 4 are going to be the exact same. I just change the signs because all students take calculus. That's it. In fact, that's how you could fill out the rest of this circle, is I could just copy all of these values and say 1, I can say square root of 3 over 2, 1/2, square root of 2 over 2, square root of 2 over 2, 1/2, square root of 3 over 2. I can come over here, write the exact same stuff, 1/2, square root of 3 over 2, square root of 2 over 2, square root of 2 over 2, square root of 3 over 2, and 1/2. I can write all of those, and then I just go along and say, all things are positive. Sine is positive, so I negate all of my cosines. Tangent is positive, so both my cosine and sine are going to be negative. C, cosine. Cosine is positive. That means all of my sine values are negative. The unit circle isn't a big mystery. It's a special right triangle on repeat mode. You ever get a playlist of just 6 songs and you listen to it over and 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 over? Or are you neurotypical? Yeah. Okay. That's the unit circle. The unit circle is just quadrant 1 copy pasted into the other ones. It's just reference angles now become coterminal angles. My cosine sine values might have their signs changed based on all students take calculus. The unit circle is just special right triangles, which is why you have to know it now, because when you go to trig, he will not say, go ahead and have your notes with your unit circle on it. You should just know it, because it's just special right triangles. Now, what I always recommend kids do, next to this, it is not a part of the unit circle itself, but what I strongly recommend kids do is next to every one of these coordinates, also write its tangent value. That way you can look in one spot for all of your answers. What would be a good color? Because I already use those. Orangish? Do the orangish again?
Outside of just writing
Yellowish?
convenience, like lie on the unit circle.
It doesn't. Tangent is a ratio between opposite and adjacent. It's the ratio of y to x. That was our coordinate shortcut. It doesn't lie on the unit circle. It's a ratio of those two things. It's a ratio of the coordinate, y over x. So put 1/2 over square root of 3 over 2. Dividing by fractions easy as pie, flip a second, multiply. That'd be 1/2 times 2 over square root of 3, 2's cancel. Or you just look at your chart and it's square root of 3 over 3. It's 1, it's square root of 3. So what am I going to do to those 3 values for the other quadrants? All of its trig ratios are the same, positive or negative. All students take calculus. Tangent is negative in this quadrant. Tangent is negative in this quadrant. Tangent is negative in this quadrant. And then I move down here. I write all the same things. Square root of 3, 1, square root of 3 over 3, 1, square root of 3. Down in quadrant 3, are tangent values positive or negative? All students take calculus. It's because I'm going to put a negative 1/2 over a negative root of 3 over 2. The negatives will cancel. I come over here and it's all the same stuff. Square root of 3, 1, square root of 3 over 3. But now it's going to be y over x. It's going to be a negative over a positive. So all of these become negative. Again, the tangent values are not a part of the unit circle itself. I'm just telling you to write them there so you don't have to reinvent the wheel every time. Now that I have all of stuff, I want you to go back and think about just our review yesterday. Think about that problem that says, find the exact value of these trig ratios. When it said, find the sine of 5 pi over 4. You had to think, all right, 5 pi over 4. It's in quadrant 3, so sine is negative, and it's a reference angle of pi over 4, and pi over 4 is square root of 2 over 2, so negative square root of 2 over 2. Now I'm going to say sine of 5 pi over 4, and you're going to look over here and say, yep, done. Now I'm going to ask you, what's the cosine of 11 pi over 6? Cosine sine, 11 pi over 6. It's square root of 3 over 2. Done. That's it. The unit circle is everything we've been talking about smashed into one place. Can you do this in reverse? Can you do this with negatives now? Look at your circle. What is the sign of negative 3 pi over 4? One pi over 4, 2 pi over 4, 3 pi over 4. Sign, negative root of 2 over 2. The unit circle is cheat code. The unit circle is old school PlayStation 1 Game Shark. Just pop it in, boom, you win. The unit circle does everything for you because it's just those ratios on repeat. So now when I ask you, what is the sign of pi over 3? You're going to go to pi over 3 and you look at the y coordinate of it, root of 3 over 2. I go to 135 and I look at the x part of the coordinate. I go to 270 and, oh, did we not write those? Tangent is y over x. Go to your quadrantal angles. Y over x. When I'm down at 270, y over x is negative 1 over 0. What's the tangent of 270? Undefined. You can't do it. Cosecant of 11 pi over 6 just got way easier because I know that's 1 over the sine of 11 pi over 6. So I go over to 11 pi over 6. I see the sine, the y part of the coordinate, is negative 1/2. So I just flip that. Do you see how I pace the room for 5 minutes, come up here and write all 4 of them in about 3 seconds? It's the same thing over and over and over. Look them up, fill them out. Are you seeing where having your own unit circle written on a separate sheet of paper, a note card, something like that, would be beneficial for the remainder of the unit? Instead of having to flip back to this page over and over and over and over. Okay.
Would you go as far as call this the Trig Bible?
More like the Holy Grail. This is everything that trig is based off of.
I'll meet in the middle and call it the Trig hand grenade. Holy hand grenade.
Holy hand grenade. Where is...
Oh, this is circle.
Where's PreCalc? PreCalc. Student. 4. Where's our super cheater? Copy link, poke, remind. Announcement to all of PreCalc. It's not often that someone texts you a link and you're eager to poke it. So square root of 3 over 2, 210 is 5 square root of negative. Nope, positive. Square root of 3 over, oh wait, no, it's cotangent. Square root of 3, 7 pi over 4 is just square root of 2. What I just sent everyone is the unit circle with angles in degrees and radians, with cosine, sine, tangent at every one of my angles. And then off to the side, because we are also going to start talking about arc functions and where they're restricted on here. Remember, commandment of domain number 4. I said we would get there. We're getting there. I have the half circles on here so that we don't have to rethink the circle in terms of negatives. So this is now on your phone. Okay? I have had kids just print that out as their big unit circle cheater. Okay? Now, this is talking about a periodic nature of why I have a unit circle and the circle can continue past 360 or 2 pi. You all have a unit circle in front of you. I want to talk about this in terms of coordinates. If I asked you what is the sine of 0, are you looking at the x or the y portion of the coordinates on the circle? Okay, look at the y portion of the coordinates on the circle. What is the sine of 0? 0. What's the sine of pi over 4? What's the sine of pi over 2? 1, right? The y portion of the coordinate. What's the sine of pi? What's the sine of 3 pi over 2? What's the sine of 2 pi? What if I kept going? Now what's the sine of 5 pi over 2? Sine of 3 pi. The sine of 7 pi over 2. The sine of 4 pi. What if I went the other direction? What's the sine of negative pi over 2? The sine of negative pi. The periodic nature of trig functions. Section 4, tomorrow. How do I graph these things? Have you ever heard of AM versus FM radio? Amplitude modulation versus frequency modulation. Amplitude of a sinusoidal graph versus frequency modulation of a sinusoidal graph. You all went through physical science. Do you remember talking about electromagnetic radiation in terms of waves? That's where all of this heads. When will I ever use this? Particle physics. Sound waves. And because it repeats itself over and over and over, I ask you, look at all the y coordinates, what is the lowest that sine values will ever go? What's the highest they'll ever go? You all have a calculator in front of you. You all in degrees. I dare you do arc sine of 1.1. Thou shalt not take arc sine and arc cosine of a value whose absolute is greater than 1. Commandment number 4 of domain is live as of tomorrow. So when I'm talking about the cosine of 11 pi over 4, even though that's not on my circle, I know that by subtracting 2 pi, which is 8 pi over 4, I have a coterminal angle of 3 pi over 4. I don't need to know the cosine of 11 pi over 4 because I can go to 3 pi over 4 instead. I don't need to know the cosine, or sort of the sine of negative 2 pi over 3, because I know where negative 2 pi over 3 is on my circle. I can add a revolution to it and know that its coterminal angle is at 4 pi over 3. So the sine of 4 pi over 3 is going to be the exact same as the sine of negative 2 pi over 3. This is all stuff we've been doing, but now it's right there in cheat mode. No. Yeah, negative. Tangent of 19 pi over 6. I'm like, no. Subtract 2 pi. It's bigger than 2 pi. So I will turn that into 12 pi over 6. Now it's the tangent of 7 pi over 6. My coterminal angle. So, tangent. Good thing I wrote my tangent values next to all of these so that I don't have to figure out y over x. I don't have to reinvent the wheel. Instead, I just know that the reference angle is pi over 6, and the tangent of pi over 6 is square root of 3 over 3. And I'm in third quadrant, so it's positive. The unit circle is cheat mode. The unit circle is the answer to all. The unit circle is a real good example of why Pythagoras thought that you could just know enough math and become omnipotent. Because everything boils down to just these triangles. So if you know enough of this, you can describe all of trigonometry. Those three. They're not on your unit circle, but their coterminal angles are. All you got to do is look up their coterminal angle on a unit circle. You don't have to add or subtract 2 pi either. You can just count. If it's 15 pi over 6, well then just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15 chunks of pi over 6. You can just count around the circle real quick. You end up at that coterminal angle of pi over 2. All was number. Number is the substance of all thing. Number rules the universe. Number is the cause of all things corporeal and incorporeal, gods and demons. Welcome to the cult of Pythagoras. It is literally right there above Matt's head, the cult of Pythagoras. Okay? Because how did I get the circle? I did it by Pythagorean theorem and distance formula to create all of the sides. Do you see how people start to come up with number conspiracy theories? Have you ever heard of the conspiracy theory for the number 23? Or watched the movie, The Number 23? You want to watch Jim Carrey in a role that you don't want to see Jim Carrey in? Blow your friggin' mind because he turns out to be a serial killer who snapped his own brain? Like, there is so much interconnected between this, and getting the unit circle is just a scrap of it. Short version, you can find 23 in virtually everything from the combination of letters and their position in the alphabet to dates and times by add, subtract, and multiply, doing arithmetic operations on words and letters and dates. You can say essentially the entire world is created by the number 23. And then it finds that, and then people start to think that their destiny is predetermined. I was supposed to kill my mother, like that kind of stuff. And that is that. Okay? The unit circle is just look at the circle. Do you think you could recreate the circle if you knew your special right triangles? That's your homework. Study up. Because, where to go? Tomorrow, student shared. Come on, Frank, hurry up. This is what you got coming at you. A blank piece of paper, no notes, no calculator, no nothing. I make sure that some stuff is torn down off of the walls. If you can fill out the triangles, you can fill out the chart. If you can fill out the chart, then you can fill out the entire circle. I will also send that to you so you know this is what I have to fill out. You won't have a specific assignment. You just better know this. Okay? Because that's probably how we're going to start tomorrow. Hi.
Is there any way we could print that off so we could like try doing it tonight?
I said I'm going to send it to you right now. Okay. So, that is that.